I wanted to make a dopamine drip math problem video for you guys so that you can watch it whenever you needed help or a refresher on how to do this problem. So in Clark County and most systems, EMS systems throughout the country, we use a 1600 microgram per ml concentration of dopamine. Sometimes there's a pre-made bag that you just hook up a 60 drop tubing set to, and other times, like at Community Ambulance, we have a vial of 400 milligrams and a 250 ml bag of normal saline that we have to mix the two. Other systems, they'll have either 800 milligrams of dopamine and you have to mix that in a 500 ml bag. Both of these will give you a 1600 microgram per ml concentration. So the problem will basically have this information and a question at the end: how many drops per minute or how many drops per second. So when you read the question, try and pull out this information. Usually the first thing I do is pull out the mix. For the quizzes, there will be different concentrations. You won't end up with 1600 micrograms per ml every single time. And the purpose of that is just to see if you understand how to do the math problem. Okay, so start off with the mix. So we have 400 milligrams and 500 ml. So write down 400 milligrams. And we have to get it into micrograms. Okay, we have 400 milligrams of dopamine, but our dose is micrograms. And the way to do that is just to add 3 zeros. So 1, 2, 3. So we have 400,000 micrograms of dopamine. And it's in 250 ml, so you divide that by 250. When you put the 400 milligrams in a 250 ml bag, we want to see how many micrograms are per ml. So you divide that. So 400, 000 divided by 250 equals, and that's how you get the 1600. Okay, so this is 1600 micrograms per ml. That's our concentration. The next thing you want to do is figure out the patient's weight in kilograms. Here the question says 180 pounds, but our dose per protocol is in kilograms. So what you do is you take the 180 and you times that by 0.45. And usually the way I do math problems is with a calculator, but I write out each step separately so I can see where I make mistakes, if I make any. So 180 times 0.45, here, let me do that right here so you can see. 180 times 0.45 equals 81 kilograms. 81. The other way to figure out kilograms is 180 divided by 2.2, and that equals 81.8. So we use 81. All right, the next thing you do is you set up your dopamine math problem. So put a line and put the 1600, the concentration, put the concentration down here. Sometimes the problem will give you the concentration. Maybe it's like 800 micrograms per ml concentration or 2400 micrograms per ml concentration, whatever it is. Put that on the bottom. And then, so first we take our dose, which is 5 micrograms, times it by kilograms. So we have 81 times 81, and then we always times it by the drops of the tubing set. And in the dopamine drip, it's 60 drop tubing. Okay. Maybe the problem will have a 15 or 10 drop, but usually if it doesn't say anything about the tubing, always go back to the 60. So 5, which is our dose, 81, which is our kilograms, and then 60 drop tubing is for the drips. And then you divide all of that by 1600. So let's work this math problem out. 5 times 81 times 60 equals 24,300. 24,300 and divided by 1600 divided by 1600, and that equals 15.1. 15.1. And that gets you drops a minute. So that answers this first question here, how many drops a minute? And you want to do 15 drops of this 60 drop tubing every minute. To get it per second, the second question here, you want to divide that by 60. There's 60 seconds in 1 minute. So 15.1 divided by 60, and that equals 0.25. So that equals 0.25. Basically what that means is, a quarter. So 1 drop every 4 seconds. If you can think about it another way, think of counting by 15s to get a minute. So 15, 30, 45, 60. So 1 drop every 4 seconds gives you 15 drops a minute. Let's look at this other math problem. So we have 800 milligrams in 500 mLs. Let's see what that is. 800 milligrams. We add 3 zeros, 1, 2, 3, divided by 500, and that equals 1600. So we have a 1600 concentration. We have 180 pounds, so 180 times 0.45, and we already did that above. We know that's 81 kilograms. And we have a dose of 5 micrograms per kilogram a minute. So 5 times 81 times 60. In question 2, it doesn't say anything about what type of tubing to use, nothing specific there, so we always go back to default, which is the micro drip set. Divide that by our concentration, 1600, and let's see if we get the same thing. 5 times 81 times 60 equals 24,300 divided by 1600, and that equals 15.18. 15.1. Okay, remember that's per minute. Define per second divided by 60, and you'll get 0.25. So these two problems are very similar. Problem 1 has a 400 and 250. Problem 2 has an 800 and 500. We doubled the dopamine milligrams from 400 to 800. And so to get the same concentration, you double the 250 to 500 cc's. Okay, so, and you get the same answer, as long as the weight is the same and the starting dose is the same, 5 and 5. Okay, question 3. We have 400 milligrams and 250 mLs. So 400, add 3 zeros to get micrograms. Divide that by 250 mLs, and that gets you 400, add 3 zeros, divided by 250, and that equals 1600. Okay. This patient is 192 pounds, so we'll do 192 times 0.45 192 times 0.45, and that equals 86.4. 86.4. And then we're going to times that by 15. That's our dose. So 15 times kilograms, 86.4 times 60. Looking at this question, does it say anything specific about tubing? It does not. So we go back to our standard micro drip tubing. Divide that by our concentration. So we have 15 times 86.4 times 60. That equals 77760 divided by 1600, and that equals 48. Let's try that again just to double check. 15 times 86.4 times 60 equals, divided by 1600 equals 48.6. That means 48.6 drops a minute. Okay, this is per minute. We want to know per second, so we divide that by 60 again. For 48.6 divided by 60, and you get 0.81 equals 0.81 a second. Okay. The answer could be 48.6 or 0.81. That's almost, 80% of 1 second. So almost 1 drop a second. 48 is pretty close to 60. Just a little bit slower than 1 a second. Let's look at question 4. So we have 800 milligrams in 500 mLs. And same dose, 15, and same weight. See if we get the same answer. So 800, add 3 zeros, 1, 2, 3, divided by 500 equals 1600 concentration. We take our 15, once we have our concentration, now we need our kilograms, so 192 times 0.45 equals 86.4. So 15 times 86.4 times 60 divided by 1600 equals 48.6. Let me just do that real quick. Just by looking at the question, how can we do this quicker? We know 800 and 500 is 1600 kilogram or micrograms per ml. That's our concentration. And so we take the dose, start off with 15 times kilograms times 86.4 times 60 equals, divided by 1600 equals 48.6. Okay, that was 4. Let's look at 5. So in this question, we're going to change the concentration. So when you see this, mix 200 milligrams and 350 mLs, don't just assume it's a 1600 concentration. I'm guessing some of you were skipping this step and just assuming that the concentration was 1600 and you were getting different numbers than I was getting. This is not what we do in Clark County, but the purpose of this is not to give you a 1600 concentration. The purpose is to see if you can just figure out how to do the problem. So 200 milligrams, add 3 zeros to get it to micrograms, divided by 2, or this one's 350. 200, add 3 zeros, divided by 350. That equals 571.4. So that's our concentration, 571.4 micrograms per ml. Now we have a 5 micrograms per kilogram per minute. We have 180 pounds. We know that the 180 pounds is 81 kilograms from the previous problem. So we have 5 times 81 times 60 divided by 571.4. And that equals 5 times 81 times 60 divided by 571.4 equals 42.5. 42.5 drops a minute. See, when we lower the dose per ml, we decrease the concentration. We have to give more drops to get their blood pressure up. Divide that by 60. 42.5 divided by 60, and that equals 0.7. 0.7 drops a second. Okay. So we had 200 milligrams and 350 mLs. Give 5 per kilogram per minute. 180 pounds. How many drops a minute? How many drops a second? So 200,000 or divided by 350 gives you 571.4. We get the 5 here from the dose, 5 micrograms per kilograms. We get the 81. 180 times 0.45 gives you 81. 60 is the tubing. We divide it by the concentration, which is how we got it from this number here. And that gets you 42.5 drops a minute, and then divide it by 60 to get drops per second. Okay, let's look at question 6. So it's asking for 0.62 grams in 720 mLs. Give 8 micrograms per kilogram per minute, and your patient weighs 157. How many drops a minute? How many drops a second? So we know that 0.62 grams, we have to move the decimal place over 3 spots. 1, 2, 3. That is 0. So 0.62 grams is 620 milligrams. And then we add 3 zeros to that to get the micrograms. So 0.62 grams is 620,000 micrograms. Divide that by 720 mLs. Okay. 620,000 divided by 720 equals 861.1 concentration. 861.1 concentration. Okay, then you got to figure out the kilograms. We have 157 times 0.45. 157 times 0.45. That equals 70.65. 70.65. We have our dose, 8. So we'll do 8 times 70.65 times 60 divided by our concentration, which is 861.1, and that equals, okay, so we have 8 times 70.65 times 60 equals 33912 divided by 861.1, and that equals 39.38. 39.38 drops a minute. That's per minute. Let's double check that math. 8 times 70.65 times 60 equals, divided by 861.1 equals 39.38. And then to get second, divide that by 60. Divided by 60, and you get 0.65. 0.65 per second. Okay, so we have 0.62 grams. So a half a gram is 500 milligrams. So this is 620 milligrams. 620. Add 3 zeros, divided by our bag, which is 720 mLs. You get the concentration. It's not 1600, it's 861. Then over here you figure out the kilograms. So 157 times 0.45, you get 70. Take 8 times 70 times our drops, divided by our concentration, you get 39.38 drops a minute, which answers this question, how many drops a minute? And then to get the second question, divided by 60, and you get 0.65. How many drops a second? 0.65.